All right, guys, welcome to Chapter 8 Notes. This is 8.1, Defining and Using Sequences in Series. I am going to break this up, so sequences will be part 1 of the 8.1, and this will be part 2, so you'll have 2 separate videos for 8.1. So what we're going to do first is just fill out these tables using the given equations. So I have given you 3 different x values. We're going to be plugging in for that exponent there and just filling out the y's. So for the first one, I have 3 minus 2 to the first power, so I get 1. 3 minus 2 to the second power, so I get negative 1. And 3 minus 2 to the third power, so I get negative 5. So what we're looking at here is trying to figure out our domain and range. So remember that our x's are our domain. So if I were to list those, I would have 1, 2, and 3. And our range is our y's. So if I were to list those, I would have 1, negative 1, and negative 5. Okay, it's very similar over here on the next one. We are going to do the same thing, but this time I'm plugging them in for that x right there. So not the exponent, but that x. So I have 5 times 2 squared plus 1, and I get 21. Then I have 5 times 3 squared plus 1, I get 46, and then 5 times 4 squared plus 1, and I get 81. So again, the x's listed are my domain, so 2, 3, and 4, and the y's listed are my range, 21, 46, and 81. Okay, so those lists that we were just looking at are actually sequences. So sequences are an ordered list of numbers. Okay? They can be finite or infinite, so meaning a set number of terms, which is what we had in the last slide, or an infinite number, meaning it goes on forever. Okay? Those terms are the values in the range. So when I say terms, I'm really thinking about the range, the output, and the domain are the positions of the terms. So when I think about these, I think about maybe the first term in our first table on that last slide. So first term was a 1. So my first term is the x, and that actual term number was 1. Okay, so you're thinking kind of like an ordered pair, 1, 1. And if the domain is not indicated, we always assume that it starts at 1. So we're starting with the first term. Then we're going to be able to tell the difference between a finite sequence and an infinite sequence. So what we just looked at were finite sequences because we just had 3 x values, 3 y values. And what we're going to look at next are infinite sequences, which means it goes on without stopping. So we can actually use that ... to tell us it's going to keep going. So here are a couple infinite sequences down at the bottom, and it's just telling us to write the first 6 terms of the sequence. So we are going to plug in 1 through 6 for n to figure out what those term values would actually be. So I'm going to start by plugging in a 1. Okay, so assume, remember, that the domain starts at 1 if it doesn't tell us. So I'm plugging in a 1 first, then I'm plugging in a 2. Remember, you can pause the video at any time. Then I'm plugging in a 3, then a 4, and a 5, and a 6. Okay, so I get 7, 9, 11, 13, 15, and 17. Those would be my terms or the values in my range. So if I said, what are my range values? These would be my range. And let's pick a different color here. These would be my domain. Okay. Let's go ahead and try the next one. So again, I'm plugging in 1 through 6 for that n there to figure out what the first terms are. So I have negative 3 to the 1 minus 1, which gets me 1. Be like to the 0 power. I have negative 3 to the 2 minus 1, so I get negative 3. Negative 3 to the 3 minus 1, so that's 9. Negative 3 to the 4 minus 1, I get a negative 27. Negative 3 to the 5 minus 1, I get 81. and negative 3 to the 6 minus 1 equals negative 243. So if I were listing out my terms, that would be 1, negative 3, 9, negative 27, 81, and negative 243. Okay, so that is the terms, the numbers in their range, or your outputs. Okay, what we're going to work on next is actually using those terms to work backwards. So we're going to describe what's going on, we're going to write the next term, and then we're going to write a rule for the nth term. So if I wanted to plug in and find the 20th term, I would have a rule to do that. So on this first one, we got to figure out what the pattern is. Oops. Going from 4 to 1, and then 1 to negative 2, and then negative 2 to negative 5. So most of us are looking at this one and thinking, okay, minus 3 every time. So to find my next term, I am going to subtract 3 again. So my next term, I get a negative 8. And then I have to figure out how to write those equations like we saw on the last slide. So they looked like this, and then they had something that was related to n. So if I plug in a 1 here, I should get 4. If I plug in 2, I should get 1. If I plug in 3, I should get negative 2. So what I like to do sometimes is actually think about them like points. So what I'm plugging in are those first numbers, those are the numbers in my domain, and then my terms are the y values. So every time this is constantly changing by a negative 3. So I'm thinking maybe it's a constant rate of change. So I'm thinking it has something to do with slope. So I might graph these just to see what it looks like. Okay, it is pretty linear here. So what I'm going to think is, well, if I know how to make the equation of a line, I can use that. So I've got y equals mx plus b to help me out. So this is my slope. That's what we said it was changing by each time. So we said it was changing by a negative 3. So I know my slope is negative 3. We're going to use n instead of x because n is our term number. And then I just have to figure out what that y-intercept is. So if I kept going on my graph and I went in the other direction, so up 3 and left 1, instead I would see that that is at a positive 7. So here is my rule for my nth term in the sequence. Okay, for the next one, remember I'm looking to figure out how they are related to those term numbers. So first term and negative 1, 2 and negative 8, 3 and negative 27. So remember on this one, it might be a constant like the last one, or you might be looking for a different pattern. So to me, this one is screaming, these numbers are all perfect cubes. And if I take 1 cubed, I get 1, 2 cubed, I get 8, 3 cubed, I get 27. So my rule here, I'm taking the negative value of my n, that's my term number, and I'm cubing it. Okay, so my rule for my nth term looks like negative n cubed. And to find my next term, I just need to take that next value, which would be a 5. So negative 5 cubed, which would get me negative 125. Okay, next one, I have 3, then I have 1.5, then I have 0.75, 0.375. So this one I'm looking at is dividing by 2 each time. So my next term, I'm going to divide by 2 again, and I get 0.1875. There's my next term. And then I just have to figure out what is happening in order to write it. So I'm going to actually write these as fractions to help me out with that. So I'm looking, and every time I have a 3 on top when I write it as a fraction. So I'm going to use that to help me write my rule. There's always a 3 on top. And then I just have to figure out what's happening on the bottom. So I have 1, and then 2, and then 4, and then 8. These are all numbers that can be written with a base of 2 and an exponent. So what 2 to the what power would get me 1? Well, anything to the 0 is 1. And then I have 2 to the first, 2 squared, and 2 cubed. So what I'm doing is actually relating this to the term number. So how is this first one related to 1? How is this related to 2? How is this related to 3, to 4? And we see that it is 1 less. So I have 3 over 2 to the n minus 1 power. Okay, and last one on this slide. This one's a little bit different, so I'm adding 2, and then adding 4, and then adding 6. So to find my next term, I would add 8 and get 20. There's my pattern. And then I have to figure out what the nth rule is. So again, I am comparing that to those term numbers. How are these related? And I notice that if I take 0 minus 1, or times 1, I get 0. And this one, I get 1 times 2. Here's my term numbers. Okay. 2 times 3, 3 times 4. So each time I'm taking that term number and I'm multiplying it by 1 less than the term number. So I have my term number times 1 less than my term number. We're going to try 4 more of those. So this next one here, each time it looks like I am adding 2. So to get my next term, I'm going to add 2 as well. So 11 is my next term. This one is very similar to the first one of these that we did because we are adding or subtracting. This is going to be linear, so I can think of slope, and I can write these as points. So maybe it's 1, 3, and 2, 5. Remember, you can find your slope here, or you can look at what we were adding each time. So this time, I'm going to have a 2n, and then when I solve for that, or maybe I graph it and I go backwards, so my first point is 1, 3. If I go down 2 and left 1, I'm going to end up at a positive 1. So here's my rule for my nth term. Okay, the next one here, again, I'm looking at how they compare to those term numbers. So sometimes I like to make a table. And how do I figure out what is happening? I'm going to look at how they relate to each of those terms. So 1 times 3 gets me to 3. 2 times 4 gets me to 8. 3 times 5 gets me to 15. 4 times 6 gets me to 24. So I'm seeing that I'm taking my term numbers and I am multiplying by 2 more than my term number. So 4 is 2 more than 2, 5 is 2 more than 3, 6 is 2 more than 4. So this is my term number times 2 more than my term number. Okay, so my next term, I would take 5 times 7 and get 35. Okay, the next one, I'm noticing that my term is going from positive to negative, so I know that this is something with exponents. So on this one, I'm taking something to an even power, something to an odd power, and something here to an even power, something to an odd power. That's how I'm switching back and forth. So I'm just trying to figure out how or what number we're using here. So we can actually use one that we've already done to help us out. We figured out 1, 2, 4, and 8 were all something we could write with a 2 as a base. And we also figured out what those exponents were. So we had a 0, 1, 2, and 3. So to find our next term, we're going to have negative 2 to the 4th and get that 16. And our rule looks like negative 2 to the n minus 1. So very helpful to look back at ones we've already done. Okay, and last one, again, I'm going to look at how they relate to those term numbers. This time I see that that 17 is a very weird number. So I'm thinking, okay, well, how can I get from 4 to 17? I can do 4 squared and then add 1, see if that works. 3 squared and then add 1, and it looks like it does, so I found my pattern. So next one would be 5 squared plus 1, which is 26, and my rule would be n squared plus 1. Okay, these will get easier as we go on through the chapter, so just make sure that you are looking for patterns to start with and trying to at least figure out if you can write the next term in the pattern. And we will continue in part 2.